and it will be available online afterwards. And if you have any questions at any point, please feel free to put them in the chat or to click the Q&A button underneath and leave them there, and we'll address them at the end during the Q&A. So without further ado, I'm going to go ahead and hand it over to you, Nelson. The floor is yours.
Thank you very much, Amanda. Appreciate the invite, and let me share my screen here. Let's see, and hopefully I'm sharing the correct screen. Are you able to see? Okay, and hopefully you see it moving too. Well, hold on. No, not yet. See it moving now?
Yep.
Okay, great. All right, so thank you very much, Amanda, for the invite, and thank you to New York Sea Grant, and Dr. Fallon, been a long time partner of ours at the National Weather Service, helping us work on coastal and rip current science and outreach, and so always great to be able to present, kind of tag team with her. So what I want to present today is talking a little bit about some of the coastal, especially flooding impacts and hazards and impacts we have in the local area. And the two main ones really are we're talking about flooding from rainfalls from freshwater, and then also flooding from coastal storm surge. So just real quick about us, so those are two topics I'll go into, and then just how you can help us as citizen scientists. I think we're always appreciative, and you'll see through the presentation how important any kind of observations information you guys can provide on what's happening in your communities. Just real quick, National Weather Service, we're the federal government agency responsible for weather observations, weather forecasts, weather warnings, and for the the U.S. The citizens and the anybody living in the United States, and also a big thing that we do is provide weather support to our public safety officials to help them take the forecast and make them into actionable decisions, to make decisions from the forecast. So kind of connecting the forecast to their decision making to keep our communities safe. Probably, your weather forecasts, you guys are, you click on, you go to any website, listen to the media, you'll get the forecast for the next 7 days. How cold, how much rain, how much snow, but things you may not know. We're also provide marine forecasts for safe maritime travel, coastal flood forecasts, so storm surge, how that's going to affect us. We do aviation forecasts for aviation safety and keeping the airspace running, especially our three major airports. Fire weather forecasts, and like I said, weather support. And we're 24/7, 365 days a year. Covering every hazard you can think about, from warm season to cool season, and flooding in between. And so one of the things, why is, in order for us to do the job we do, critical to us are observations. Observations are kind of the fundamental part of, any kind of forecast we're doing. And as scientists, it all starts with observations. Then you can, based on observations, and then using your knowledge of, how, your area of science, how things work, and then trying to kind of solve a problem. It really starts with good observations, and that's where community, you as a community citizens can really help us out. It's just situation awareness, what's going on, can help us in terms of improving more timely and impactful warnings when we know what's happening in terms of ground truth. Improving our weather support ahead of an extreme event, if we have a better sense of what the possible impacts are from different meteorological, marine, and tidal conditions that we've been able to kind of study from your impact information we get, correlating with those type of that type of information, and then for future events we're able to kind of provide more impact and decision grade information. Helps us kind of refine flood thresholds, post-event verification, validation, and then a whole list of other things in terms of mitigation, recovery efforts, and then just kind of furthering the science. I think all these things are really important in terms of how we can use observational information. So we'll start with flash flooding, riverine flooding. So what are the key ingredients? For our area, we're affected by coastal storms. We're affected by thunderstorms. We can be affected by tropical systems. All of them can bring heavy rainfall to our area. The fact that we're near the ocean, already an ample source of moisture. So, for flooding, especially flash flooding, what are the three keys, or how much rainfall is falling in a specified amount of times? Rainfall rates. Generally, we're looking at, especially, how much is falling in 1 hour, 3 hour. How much, what's the coverage? Is it just localized, say a thunderstorm in one area, or is it across the whole island? And then what's the duration of it? Again, are we seeing these high rates of rainfall just for maybe a half hour, an hour, and then it's done? Or is this going to be several hours where you're going to really see impacts? So then we take these, and this is what we're trying to forecast for with the modeling, with our understanding of how the atmosphere works. We're trying to forecast for those three factors, but another important factor in terms of, does this translate into flooding, is really the non-meteorological characteristics. So soil conditions. We're a very sandy soil here on Long Island, which is fortunate. It helps for permeation of the rainfall, and less versus, say, New York City, where it's very 80% impermeable surfaces, where a lot of heavy rain can turn into runoff. Are we urban versus, especially as you get towards the city versus, maybe more rural? Are there orographics, which luckily we're not dealing with, but as you get further north and west of the city, do we have riverine basins? We have some small rivers, streams, but really more so Northeast New Jersey, Lower Hudson Valley. As you get into Connecticut, other areas have really kind of flashy stream basins. So all those things, and then the big thing for us is probably tides. Groundwater can be another one that are compounding factors when you take heavy rainfall. In addition to these factors, these are all things that are not maybe modeled for, that we have to take into account as meteorologists, and especially that's where the impact information can be really helpful. Is when we see these other factors, we know, basically based on this rainfall, this is probably what will happen, but based on these other factors, what is actually happening? That's where the observations help us. So, like I was saying, in terms of what are the types of flooding? We can have thunderstorms are actually, climatology wise, 70% of the flash flooding events we have are from thunderstorms. They're usually predictability, especially, where exactly are they going to form? How long are they going to be over an area? Are they going to kind of move over the same areas? What are the rainfall rates? There's lower predictability in that, so shorter time ranges in terms of how far we can provide a forecast. Sometimes not until it's occurring, but it can be really intense rainfall. Thunderstorms, you have a lot of moisture that's being lifted well up into the atmosphere, can cause really high intensity rainfall rates, 2, 3, 4 inches per hour over a short period of time. This is an example here from July 9th of the radar, an area here in eastern Orange County that saw in excess of 6, 7 inches of rain in 3 hours. And unfortunately, we had a fatality and a lot of a destruction to infrastructure in that area. And then, a smaller, in terms of frequency, but, just as it could be as impactful, but over a larger area, tropical systems, where we can see for several hours, you can see rainfall rates 1, maybe 2 inches per hour. Some examples are Irene, Floyd, where you have the tropical moisture. You don't necessarily have the thunderstorm activity, but you have tropical moisture. So a lot of moisture that's being lifted, that you see for a long period of time. 1 inch per hour rainfall rates. And so it's not uncommon, or it's not out of the possibility in, 24 hours to see 15, 20 inches of rain. The worst type of flooding event we can have in our area is really kind of a hybrid of where you're getting thunderstorm activity with the tropical, a tropical type moisture tropical event. And these are two examples. On the top row here, we have Ida, which I think everybody is quite familiar with in terms of the remnants of a tropical system interacting with some increased moisture from the Atlantic, the remnant moisture it had, and then also instability that's more of a summertime instability, kind of convective instability that allowed for a lot of thunderstorm activity with this event. That gave us rainfall rates 3, 4 inches per hour, especially far western parts of Long Island, and more, what we saw in New York City, Northeast Jersey, Lower Hudson Valley, creating, really extreme rainfall. with this. Just all it took was 2, 3 hours of these rainfall rates, and we saw destructive and deadly flooding. And then the lower left is actually one that affected Long Island in 2014. We saw rainfall rates of 3 to 5 inches per hour. It wasn't a tropical storm, but it was tropical moisture that was being lifted right along a weak boundary, and we saw rates 3, 4 inches per hour for 2, 3 hours, 6 to 10 inches of rain. Both of these were 1 in 1,000 year events, so 0.1% probability of occurrence in any given year. And what makes it interesting is that you think that doesn't happen too often, but we've actually had 4 of these events in the local tri-state area in the last 10 years. So something to say about, we're seeing increasing frequency of these high rainfall type events. And this is just an example of some of the impacts from that flash flood. Back then, we didn't have the ability to put out flash flood emergencies, but if this occurred today, we would put that out. Ida was the first time we did issue a flash flood emergency. So, I talked about observations. How do we issue, flood warnings? The same things I talked about in terms of the observations. The radar information is really the key. These are just some examples. We can look at the reflectivity on a radar. How heavy is that rain? Size of raindrops, things like that. But then we can incorporate with that rainfall, that radar information. We can look at satellite information. How cold are the cloud tops? How much rising of moist air into the atmosphere, meaning heavier rainfall, surface observations. There's a lot of other, information that can be merged with the radar information and observational information to give us a sense. And even looking at land types, urban, riverine, things like that, the types of soil, to give us information on how much of that rain that's falling at a specific rate, how much is that turning into runoff. So we have all that information. But again, it's all, and we can look at model information. We have our forecaster experience, but we need the ground truth, what's actually happening out there, to really correlate what's happening. So, and that's a really key for us in terms of one thing in terms of the observation is how they can help us, citizen observation, what's happening outside, to help us to better, more accurately and provide more timely warnings. We do issue flash flood warnings when we see on radar and satellite and, from surface observation, from the modeling that, all right, we have intense rainfall moving to an area that maybe we can't handle it, but to really know exactly, are those rainfall rates correct? What is that, how is that translating to impacts? We need the information of what's actually happening on the ground. So basically, in a basic case, when we're seeing these heavy rainfall rates move to an area, we may issue a standard flash flood warning. A few roads we're expecting to, become flooded, become impassable. Maybe some flowing water over them. Maybe could have 2 to 3 inches standing water. Could get basement flooding for, say a neighborhood or a few neighborhoods. Some first floors of a few buildings being flooded. Maybe a few rescues of people trapped, because their car stalls. But really the next level, we have impact-based warnings where we can actually accentuate the alerting of these flood alerts to go to more of a considerable or catastrophic level of flash flood emergency, where we can alert these. You'll get them not only just on the internet, but you'll get them on your cell phone. The way we do that is the radar, all the meteorological information we're getting in. But what's key is, what are people seeing on the ground? And this is an example: standard flooding. We're getting reports of maybe some roadways, some exits closed, roadways closed in a direction or two, underpasses flooded. We're getting some flooding where enough where cars are getting stuck. That's standard flash flooding. But if we're starting to, if we're getting more reports that this is expanding, maybe more in towards, it's becoming more widespread. We're seeing more impacts on major roadways. We're seeing more impacts to property, and it's, the threat to life looks like it's escalating. Plus, we're seeing more rain and intensifying rainfall rates coming in on radar. That's when we can elevate to the next level, a considerable flash flood warning, and then you'll get a wireless emergency alert, and that's going to tell the public or anybody, they need to get to safety. And some examples of what that would look like in terms of that severity of flash flooding. These are kind of combination of of Ida, and a couple of other events. And just kind of, I'll skip through these really quick. And then the highest level is the catastrophic flash flooding event, where we're getting reports of these, widespread flooding, increased severity, increased depth of life, and the rain's continuing, and where it's becoming evident that unless people take immediate action, emergency management might not be able to get to them. There's a likelihood that they may, they lose their life. And so that's the highest level. Unfortunately, what we saw in Ida. But what's helping us is that type of information, that ground truth. We can put in this extra messaging. We can, get the alerting out in terms of the wireless emergency alerts, to be able to get people to take action. And just some examples of that catastrophic level of flooding. So hopefully it kind of gives you a little sense in terms of the freshwater flooding, what we see, but also coastal flooding. That's a big issue for us as well. Instead of from the rain coming from the sky, we're looking at a large coastal storm. Could be a nor'easter, could be a tropical storm. Big, large wind fields over a large expanse of water, pushing water towards the coast, and that water, flooding normally dry ground. So we can get it in two ways. The highest level inundation events, storm surge events. This is just kind of looking at New London, kind of a good proxy in terms of some of the, where some of the informational sites we have to look at, like some of the biggest events. But you can see 1938 hurricane, 1954 hurricane, the highest water levels kind of reached October 2012. So that was Sandy. But so really the most extreme events usually are going to be tropical, especially hurricanes. But then, we can also see it from big time nor'easters. November 25th, 1950. Another one is the 1992 nor'easter. Two of those are really kind of the benchmarks, where we saw some areas saw 3 to 5 feet of water above ground, which is becoming life threatening. So that's another threat we have, is it could be either extratropical or tropical. And the main stressor for that is the wind. It's kind of going to be the intensity of the storm, the track, the speed of the storm, the size of the storm, that wind field around it. And what makes our area, just the geography of our area, is kind of a funnel. So whether you're on the North Shore of Long Island, the Twin Forks, the South Shore bays, right along the beachfront, there's really no safe place if you're near the water. As we've seen with some of the events in December and January, strong southeasterly winds pushing water right towards our, battering the beachfront, but also into our southern bays. And then, you can even have a wind shift, which will push it from the western Great South Bay into the eastern Great South Bay. We saw moderate to major flooding. East-northeast events, really, again, western Great South Bay, the Twin Forks, and then even northwesterly events can affect more the North Shore. So that direct wind stress is really important. Wave action, freshwater flooding, freshwater rainfall can compound that. And the other thing is we have the tides. We have the astronomical tides, a 3 to 5 foot range that we can see over, over the course of a tidal cycle. And so when does that surge come in? That wind push surge. That's all things that we have to take into account in terms of forecasting. Just some examples, the 1992, so in terms of at least benchmark storms for extratropical, in the 92 nor'easter, where we saw, just basically a slow moving storm, 3 tidal cycles of minor to moderate, but 1 tidal cycle of widespread major coastal flooding. And really, what helps us to be able to go back and study this is how much surge, what was the the factors, the meteorological and marine factors. But having photos like this really kind of gives us a sense, even though this was kind of before I was even started forecasting, really gave us a sense of what the impact of this type of event was. Another example is 1950. We had less impacts from that, so a little less ability to kind of really do a deep dive and study. But again, that's the importance of these citizens' observations. And then really quick, the 1938 hurricane, in terms of a high-end flooding event, where we saw 15 to 20 feet of surge, so 10 to 15 feet of inundation above ground, eastern Long Island into southeastern Connecticut. So what are some of the worst case scenarios between a cool season extratropical system and and a tropical system? And then, just real quick, how can we use your citizen, kind of reports? We have, if you go to this website, you'll see we have all our time of coastal flooding observations, forecasts. but and all type of wind information or hazards. But really, one of the keys is to be able to take those forecasts we provide and then use some of the visuals. And we have two visuals to really understand what is the water going to look like at your feet. And that's really the key of what we're going to do. This is an example of our coastal flood product. A lot of stuff in text. We try to relate it in terms of inundation above ground. What are the impacts verbally of coastal flood impacts, shoreline impacts? And then we put out, water level forecasts in terms of, how high the water is going to be above certain datums. But really, what do you want to know is inundation above ground, right? And so one way you can do it through visuals. If we put out an advisory, what does that mean in terms of hazards, impacts, and pictures? What does moderate mean? In terms of, so give you a little bit of sense. But really what is more powerful is being able to use visuals like mapping. In this case, we can show you, all right, we're thinking that we're going to hit the major flood threshold. What is the extent of flooding that we see when we do hit that major flood threshold? And excuse me, my throat because of getting over laryngitis. But and then in terms of how we can use your kind of impact information, a great way is our impact catalog. So what we can do is take a weather event, say a tidal flooding event, water levels got to a certain height at a tidal gauge. If you're able to send us reports of what happened, we can put that into this catalog. So we develop a whole catalog all the way from just spring tide events to tropical events. What are the impact? What do they actually look like? So you can use that mapping plus real world events to really, our emergency managers can get a real sense of what's going to happen and the public and how to prepare. And also we can refine flood thresholds, minor, moderate, so advisory, warning. We can refine all our flood thresholds that way. So I think I'm out of time here, but what I'll leave is just a few images here and just more ways of even the coastal impacts, how we can visualize it. But we can probably come back this in the Q&A, but how you can assist. We have a few websites, but I think the real key, a great website that Kathleen is going to go over in terms of My Coast, where you can actually provide visuals of what the impacts are looking like in your community while staying safe, of course, and it will correlate it automatically to marine and meteorological conditions. So excuse me for my voice, but I will pass it back to Jimena now.
Thank you, Nelson. That was great. All right. So I will hand over the mic back to Kathleen.
Thanks, Amanda. And thank you, Nelson, for a fantastic overview of the coastal and flood hazards and storm impacts that we will experience. I am pulling up my slideshow and going to hit share screen. I always think I can talk through it, but I never do. You're seeing my screen, right, Jimena?
Yeah, we see it.
I'm on full screen now, right?
Now,
all right.
Yep.
Perfect. Thank you so much. Yes, so thank you to everyone for inviting me here tonight to be able to talk about a somewhat new, about 2 years project that we've been working on in New York. Thank you, Jimena, for the fantastic introduction. I'm Kathleen Fallon. I'm the Coastal Processes and Hazards Specialist with New York Sea Grant. I work throughout Long Island. I'm based at Stony Brook University. And I'm going to talk about a project that we launched, like I mentioned, in July of 2022. And it is a partnership between New York Sea Grant and the New York State Water Resources Institute. And it is a new citizen science web tool that we are piloting and plan to expand use throughout the state. I'm going to focus on Long Island, of course, because that's where we are. That's where I work, but I do want to make sure that I put a plug in that even though it is called My Coast, we do use this throughout New York State. So not only on Long Island and in the city, but also up through the Hudson Valley and into the Great Lakes and even some of the Finger Lakes and inland waterways and communities. I would like to mention before I get started that all of the images, believe all of the images that I have used in the slideshow today are from MyCoast, and they have been submitted through our website by citizen science users on Long Island. So you might see some of familiar pictures throughout this slideshow. I'm not going to dwell on this. I figured Nelson would do a fantastic job of teeing this off. But just to reiterate that here on Long Island, we experience coastal flooding as a result of tidal fluctuations, storm surge, and of course, sea level rise. It's expected on, that should say, stormy days. But also we are seeing more incidences of flooding on sunny days, which is more related to sea level rise. And of course, we care about coastal flooding because there are impacts to infrastructure, particularly in the flood zone, which as sea level is rising is expanding. In addition to flooding, we also experience coastal storms. Again, to reiterate what Nelson already mentioned, we are in this lucky situation where not only do we get hurricanes and tropical systems that cause flooding and storm impacts, but also nor'easters and blizzards in the winter. And as Nelson alluded to already, there's been an extensive history of coastal storm impacts on Long Island, as well as damages. So this is not something new to our coastline, but it is something that we are still dealing with on a day-to-day basis. Storms that bring precipitation, wind, large waves, storm surge, causing extensive flooding and erosion in our communities. And again, with we are anticipating and predicting that coastal flooding and coastal storms will become more frequent and intense as climate is changing. So as Nelson was mentioning, I'm going to talk today about this tool, MyCoast, which we are using in New York throughout the state to collect photo visual reports of coastal storm impacts. And again, not just during storms, but also some of that flooding that we're seeing now, or even more frequently during sunny days or unrelated to storm surge. So here's our website. This is through www.mycoast.org/New York. We have a website. This is also available on iPhones or Androids through the App Store. So there is also a phone application. So you don't have to take a picture with your phone, go home, upload it onto your computer, and upload it onto the internet. You can directly upload photos through from your phone through the app. So in New York, again, we're using MyCoast to help document New York's changing water levels and weather impacts. So what is MyCoast? I'm just going to move this so I can see my full presentation. So as I mentioned, it is a web portal. It's a website and phone app that is used to collect and also analyze pictures and data related to flooding and storm events. So essentially, it's very simple. You as a volunteer, as a citizen scientist, as a homeowner, as a floodplain manager, whatever your role is when you're out, you snap a picture of flooding, storm impacts. Obviously, as Nelson already mentioned, when it is safe to do so, we definitely do not want anybody going out and putting themselves in harm to take photos of during storms. So once it is safe to do so, you can document the flooding, the storm damage. You take your photo, you upload it through the MyCoast portal. And MyCoast, one of the great benefits of MyCoast and one of the reasons why when exploring different apps to use, we decided to go with MyCoast is because it automatically links your photo to real-time environmental data. So this photo here was taken in Amityville, Lindenhurst area This is the exact location that that photo was taken. And you can see here that they have the tidal buoys, stream gauge data, and I'll show you more as to what the website actually shows you. But the great benefit is that this photo is automatically linked and geolocated onto maps and linked to the environmental data. So who is engaged? Who is MyCoast for? And the answer really is that it is for everyone. And why should everybody use it? Because this information that is collected through MyCoast, it is offering us an ability to visualize the impact of the hazards. So when the National Weather Service issues a forecast of inundation of 1 foot of flooding, what does that actually look like? Well, now we can look at that forecast and link it to that photo and see this is what 1 foot of flooding looks like in 1 foot of inundation looks like in that community. Not only that, but also there's this multifaceted benefits of using this tool. So not only are we able to visualize the actual impact, but we can also go back and ground truth that forecast, those models, and say that this model or this forecast was for 1 foot of 1 foot of inundation, and perhaps it didn't happen in that community. Maybe that community is a little bit higher ground level, but the next community over saw that inundation. So we are able to use it as an educational tool for our community members so that they can become aware of what that hazard looks like visually. And we can also use it on the academic and research side to ground truth our models and be able to see if what we are predicting or forecasting is accurate. So that is your community members, in your education, your researchers, academia, educators, but there is also an enhancement of awareness among decision makers and stakeholders that is happening. So there's this third bubble of municipalities and state decision makers who are able to see this data and be able to make maybe policy change based on informed science now. So all of these people are encouraged to be part of MyCoast and to use MyCoast, both as a volunteer and as a data user. So anyone can upload photos. There is no subscription, there's no fee, and anybody can use photos. You can go on to MyCoast right now, any one of you on this website, on this webinar, even if you've never used MyCoast before, you can go on our website and you can download photos right now without having to sign up. And so anyone can be involved in MyCoast and anybody can upload and use the photos. Again, our goals at New York Sea Grant and why we want to use this tool is to build awareness, maybe create some political will, inform municipal planning and decisions, and of course, validate forecasts, mapping projections, and overall to provide outreach and education. So just some stats. I believe I pulled these numbers last month, so there might be an update from today, but I didn't have a chance to update the numbers this before today's webinar. But so New York has three tools activated on MyCoast: Flood Watch, which tracks any type of flooding; Storm Reporter, which documents storm damage; and then CoastSnap, which is much more unique. Flood Watch and Storm Reporter, you can upload a photo, you can take a photo and upload it anywhere. CoastSnap, and I will show you in a few slides, is a fixed station. So that tool is meant to track shoreline change in one specific location. So since we've launched in July of 2022, we have over 700 registered users. We've received 1,600 flood watch reports, 75 storm damage reports, and 150 reports at Watch Hill, which is where our Long Island Coast SNAP station is located. We also have a Coast SNAP in New York City and in the Hudson. So a little bit more information about the reports. Flood Watch, again, when you upload your photo, it geotags the environmental data in it, but you also have the ability to put some additional information in there for us. One of them is the cause of flooding, if known, what exactly is flooded, what is the estimated water depth, and any other comments. Storm Reporter is very similar. Flood Watch is really meant for flooding. Storm Reporter is more about looking at impacts beyond just flooding. So maybe it's an impacts to damage to roads, marinas, buildings, or not just infrastructure, maybe some damage or impacts at the beach or coastline structures, such as a dune walkover or stairs leading down to the beach. And again, you can add any additional comments when you upload the to Storm Reporter tool. I've already mentioned this, but I wanted to again show this in more detail. The photos are automatically linked to your environmental data. So this photo was from those back-to-back January storms we had. It was this photo was taken on the 13th at 11:30 a.m. As long as you have geolocation and geotagging on your phones, it will put the date and time the photo was taken, not specifically the time it was uploaded. So you can go out, take pictures, and then go home and upload the photos at a later time or even later date. And it will still tag it for when the photo was taken. It links, as I mentioned, to tidal data. So this photo was taken almost 2 hours after high tide. So you see that the tide is falling, but we still have all of this flooding. It has the predicted water level. Some tide gauges have the ability to show an actual water level. This one does not, but you can see the predicted water level, the report time. And then it also links to the weather data. So you also have wind speed, wind direction, temperature outside, and rainfall, which is also really important to these flooding photos, because you can see that this one says really an inch of water in the past 24 hours and technically none that day. So we can use this information. And of course, again, it's located. So again, South Shore, Massapequa, Lindenhurst area. And between the sunny, beautiful picture and the rainfall, we can and of course, we know that the storm and the storm surge forecast, we can deduce that this is probably storm surge coastal flooding. This is that Coast Snap that I was mentioning. So we have our station at Watch Hill, and as you can see, it is really meant to take the same exact photo over and over and over again. If I was a little bit more tech savvy, I would have put a slideshow in here. The idea is that we can create visuals with these pictures by stringing them together and create a time-lapse video of change of the shoreline over time. We are also looking into a more research-based project with this station in looking at being able to actually quantify the amount of sediment movement. So on Long Island, we have winter, summer beaches. In the winter, we have our beaches become a little bit more narrow due to the increased wave energy, sand moving offshore. In the summer, we have nice wide beaches. So with some fancy research and modeling, we might be able to come up with some quantitative numbers about how much sediment is moving along our shoreline, onshore, offshore, and across shore. So very quickly again, as I wrap things up, how can you become a MyCoast New York user? Very simple. You go download the MyCoast app onto your phone, or you visit mycoast.org/New York. You do need to register in order to submit photos. But again, there's no fee, no anything about registering. So you register with your email, you have your photos, and you upload them and submit your photo reports. I will put a plug that New York Sea Grant does have outreach materials available for My Coast New York's. So if you are interested in sharing that information with your fellow community members, feel free to reach out to me. My email address is actually on this slide, and it is later on in my presentation. I am happy to share those materials with you. Very quickly, I did throw this slide in. I'm not going to go through it, but I did want to remind everybody that when flooding is forecasts, there are a wide variety of different things you can do, but just to focus on some of the more simple actions that you can take to reduce flood damage on your property. Simple things such as maintaining your gutter and roof, utilizing landscaping on your property, checking for leaks. If there's flooding projected in your area, maybe being able to move some of your valuable items to higher areas, utilizing flood control projects. And of course, always check the weather forecast for your area and be prepared with an emergency flood kit. And with my last minute, I will throw in a quick plug, which Jimena will talk more about. But we are dealing with coastal storms and coastal flooding. And there are unique ways that we are becoming more resilient towards these impacts. One of the more innovative and newer technologies that Long Island has been exploring recently is utilizing living shorelines. And this is a shoreline stabilization technique that uses natural or nature-based features in a more engineered way. So a quick plug to join us in Patchogue on March 30th at 10 a.m. to tour the village's new their new living shoreline, which is quite impressive. You can see a quick photo of it here. So with that, I'll wrap up. Thank you all for attending, spending your evening with us. Thank you for inviting me. My contact information and phone number and email is listed here, so feel free to reach out if you have any additional questions. Thank you.
Thank you, Kathleen. That was great. All right, so folks, now's the time when we hear from you. Do you have any questions that you want to answered by our experts today? Again, feel free to put them in the chat, or you can also include them in the Q&A button right underneath. So we actually did get a question. I see that you gave a lengthy answer, Nelson, but do you want to just briefly answer it? The question is, do you think flooding events are occurring more often, and how can we get the general public to take these warnings and forecasts more seriously?
Yeah, sure, Jimena. So yeah, in terms of the flooding events, we're seeing with the latest kind of climate research, governmental panel on climate change, and also the National Climate Assessment, looking at extreme rainfall events, those top 1%. Really seen like about, especially over the northeastern United States, looking over the last 60, 80 years, about a 40% increase in those top 1% events. And, just anecdotally, like, we've had 1 in 1,000 year events, or 0.1% probability in a year in the local tri-state area just in the last decade, which, certainly, it's something that's, notable. So, and then the projections are, even kind of in the middle of the road projection that we could see another 40% increase in these extreme rainfall events, again, over the northeastern United States. I think our kind of juxtaposition across the eastern, along the Atlantic Ocean, and a warming ocean kind of as a source for not only more moisture, but, potentially seeing some more intense storms, if not necessarily more storms, could see some more intense storms. And then so that's the rainfall end, and then on coastal flooding end, the sea level rise is probably the biggest thing. We've seen about a 1 foot rise in the last 100 years, but you look out, some of the, again, middle of the road projections for the mid-century, and we could see another 1 foot rise. So you add that kind of base. Even if we keep the same kind of frequency and magnitude of storms, you talk about another foot, especially areas, southern parts of Long Island, where you can go from minor flooding to major flooding with just a foot of water level rise. And so that's really significant. And for the amount of population we have living in vulnerable areas and infrastructure. So those things are, yeah, certainly issues that we need to think about. I think visuals and scenarios, I think those are certainly help. So I think kind of ties in really nicely with the ability to kind of get pictures of what's happening right now. I think that kind of helps us um, uh, document how these weather events, marine events, tidal events, or what are they actually causing in terms of impacts. And I think that more of that information we have kind of an anchor right now. You can do some kind of scenario-based visualizations out into the future. I think that's the only way really for things that people have not experienced to be able to kind of see a real, almost like on a real world kind of visual. I think that really helps. So that's a long answer, verbal answer for a long written answer, but
It's
hopefully it works.
yeah, no, definitely. It's a complicated like challenge, right? I see, Julia, I see your hand up. I'm gonna allow you to speak. Do you want to come off mute and ask a question?
Yeah, so my question is for Nelson. Nelson, in one of your slides, can you guys hear me?
Yep.
Okay. So in one of your slides, you showed something like predicted surge, and then the surge was actually it didn't look like it had the normal two peaks that we would expect. It had like stuff in the middle, like up and down in the middle. And I live in southern Long Island in Mastic Beach, and the three flooding events that we had in the winter this year, first of all, they were unexpected. I would have never known that they were there unless I had actually walked around the block to give my neighbor a card. That's how I discovered one. And then I started checking the NOAA alerts. Anytime they said that on the news they didn't say flooding either, which is very odd. They said maybe some sort of storm is coming. So I would check NOAA, and NOAA would say 2 feet above, which was pretty accurate down the road from me. So, but I didn't get any alerts that there was flooding, and literally the water crept up very, very slowly within a block of my house, but I got no alerts. I just happened to take a long lunch break, and I went outside and I noticed that there was water in the distance down the road. So my question is, can we improve how do we improve that? Like, how do I become more aware when there's water in my area? And if I was actually like working an hour away and came back home, I would never know that there was a flooding incident down the road. I would never have known. I would have went to work, came home, not knowing a thing. So that's one question. And how do I, as a homeowner who lives in a flood zone, how do I better protect, because they always say, oh, well, you're underwater anyway. So how do I know when it's 2 feet and it's, as I say that out loud, it kind of does sound silly, but how do I better interpret the information I'm giving, and how can I get that information more streamlined?
Yeah, no, those are great questions, Julia. And I think you are kind of in the more in the eastern Great South Bay there. Um, that is a kind of a more challenging area for us to forecast. Traditionally we see more flooding in the western Great South Bay. But what was unique with kind of these, December and January events, which typically we won't, really the last time you probably had water levels that high was Sandy. So it's been really a decade, and it probably is once every several years that we typically see something where you can get flooding into the eastern Great South. But you need the right combination of like southeasterly winds that pile the water into our general area and then into the sound, and then kind of this wind shift that actually helps everything, the water that's kind of built up in the western Great South Bay slosh into the eastern Great South Bay. And we actually saw that for a couple of events. So I think we do have a couple of sites that we do forecast for, one in Watch Hill on Fire Island, so the North Shore of the Fire Island, and then there's a Sayville gauge where we actually provide explicit forecasts. It is on our coastal. So we have a coastal flooding page. If you, I think Jimena had our weather.gov page on there. If you go on that website, you'll see there's a little coastal flooding tile. You can click on that, and there's it's kind of a one-stop shop. But I would definitely follow on there. So anytime we're forecasting water levels in that eastern Great South Bay to get above what we have defined as minor, moderate, major flood thresholds, and where you were talking about 1 to 2 feet, we were forecasting. We had coastal flood warning up. We were forecasting about 2 feet of inundation. It surpassed that, and part of the difficulty of forecasting it, but at least hopefully it would give a hint. They'll be on that page. So if you do see, the thing is, I talked about the alerting where it gets to your cell phone. Right now, that's only available if we have, really short fused flash flooding, where heavy rainfall falling that's going to create, really life-threatening inundation into the roads and properties. For coastal flooding, we don't have that type of excuse me. We don't have that type of alerting. Unless we're looking at like a tropical system where we potentially have storm surge, then you would get alerted on your phone. That's when we're expecting greater than 3 feet of inundation above ground. Excuse me.
So
Sorry
Nelson, while you're catching your breath, I'm going to jump in a second. So Nelson, I'm hearing there's gauges in Sayville and Watch Hill. It's exotic a location Watch Hill is. Everybody wants to be in Watch Hill. The risk to public safety and to structures, I think, is clearly in the Mastic Shirley area down by the water. So to me, it almost seems comical that there isn't a gauge here. I mean, Sayville, okay, we're very similar to Sayville, but we're in the Narrows. The Great South Bay, I don't know. I would think that the structure of the Great South Bay is different. We're in the Narrows. So as soon as the dunes go over at Smith Point and Fire Island, and, as soon as that goes, then we're underwater. And like you just said, you kind of confirmed what I was thinking. It was higher than 2 feet because I walked with my waders down the street, and at a certain point I had to stop. I didn't make it to the bay. I'm assuming the bay was, the first few blocks were definitely more than 2 feet. I stopped as soon as it started going over my waders. I said, well, that's enough of that. And I went back home. But put a gauge down here so we can check up on it. I think it makes sense. There's so many people, children, old people, I think it would make sense.
No, and certainly, and I appreciate that point. And so, unfortunately, we and these are gauges that our partners at the USGS have installed. The actual installation and maintenance does cost quite a bit, and so the one thing is these are put in locations that you have to find locations that are available to put a gauge. Usually, it's going to be either probably some type of public land. But the big thing is they do allow us to see how the tidal dynamics are into all the way into the mastic area. So even though it's not a gauge specifically there, it gives a lot of great information. So again, like where we can take what were the water levels at those 2 gauges. We have actually some storm surge modeling for that specific gauges, and we kind of know how the tidal dynamics will work based on the wind and kind of wave conditions into that eastern sound. And then that's where these the citizen science kind of imagery, like pictures and reports, help as well. So we don't need to have specifically a gauge. It would help, but we don't. Even with where it is right now, we're able to kind of forecast You know, the biggest challenge is the rarity of those events in that area. But I think the more we can document it, that certainly helps. And I would definitely keep an eye on that coastal flood page. We don't have the alerting right now, the wireless emergency alerting for coastal flood warnings, just for mostly our extratropical kind of coastal storms. But if there was, say, a tropical event where we were expecting greater than 3 feet, so really where it would be a concern, you know, we would want people to take heed of evacuation orders. You would get an alert. It would be a storm surge watch or warning. So hopefully that helps for now. There's continuous improvement, both on, you know, kind of the science end to better forecast for Eastern Long Island Sound, the storm surge, and then also the messaging. But appreciate the feedback, because that's things I can take back, and where, you know, things we can improve on.
Thank you, Nelson. Kathleen, we have a question for you in the chat. Do you know how the living shoreline in Patchogue fared during the winter storm event in early January?
Yeah, so I did take a ride down. I did not get out to look at it extensively, to check the damage, but it is still there. It fared, pretty well, I think. There were a lot of videos. I'm sure a lot of people saw images of, the park being, underwater during those storms. And I'm actually writing a response to Patrick's question as we speak. And you know, it's important to note that, you know, living shorelines are to become more resilient to flooding, and storm surge. They're not meant to prevent storm flooding and storm surge. So, you know, I know there was some concern, when those images came out of the park being, completely inundated. But the water did go away, like it was, as the water receded, and the park is, there, and, you know, hopefully bouncing back, and being resilient to the flooding. And again, as I'm writing in my response, to this question,
Should we
it's
read the
important.
question? Should we read it? Yeah, I
Yeah,
don't
go
know that
ahead.
people can see it. Okay, so
Oh, okay, sorry.
yeah, I don't know if they can, but just in case, Patrick asked a great question. Can you speak more about the value of natural shorelines, marshes, wetlands, etc. in these extreme surge and rainfall situations? What policy and infrastructure changes might the MyCoast data help build support for?
Yeah. So, that all being said, I did want to follow up that living shorelines, nature-based solutions are, site-specific. They are, it's best to have them engineered. And, there are a lot of factors that need to come into play to determine what is the best and appropriate, shoreline management technique. And you know, we can talk more about Patchogue during the field trip. We're happy to talk more about nature-based solutions to anybody who's interested. But you know, again, using Patchogue as an example, it's a great location because it's a park, so they have the ability to have that buffer area, and you know, deal with flooding and, being resilient, to flooding. And we are hoping that, you know, as I mentioned, MyCoast is still, we've only been running it almost 2 years, not even 2 full years yet. So we are still, working through what we can do with this data. We have had great support, obviously, from the Weather Service. We've had great support from some of the local municipal, emergency manager offices. And we hope that as it continues to grow and we collect more data and the word gets out, about the tool and the data that we are collecting, and maybe researchers and modelers start using it more, that all this stuff will, play into municipal, maybe even state policy, and other changes that need to go into effect, as we are becoming more, or as our goal to become more resilient to these coastal hazards.
Definitely. Thank you so much. Well said. All right, so I see it's 7:03. So thank you again to both of you so much for coming here today. This was super informative, super interesting. And thank you all for joining us this evening. The next and the last of our community science Long Island webinar series is going to take place April 9th at 7, and it's going to cover monarch butterflies. So you want to be there for that. We also have 2 in-person events coming up. We have a visit to the Byron Young Fish Passage that's in Riverhead, and that's March 23rd. And the one that Kathleen mentioned, the visit to the Living Shoreline, that's at Shorefront Park in Patchogue, and it's March 30th. You can register for all of those in the Community Science Long Island website, and I think Ariel is putting those links in the chat for you to directly register for those events. Again, the recording of this webinar is going to be available at that website as well. So once again, thank you everybody for joining us, and have a wonderful rest of your night.
Thank you, Amanda. Thank you, everyone.
Thank you so
Bye.
much, everyone.